Hello guys, welcome back to the Pepcoding. So in this video, we are going to discuss our next question, that is kth smallest prime fraction. So let's take this statement onto the open board. Okay. And in this question, we have given an array of sorted integers having 1 and some prime numbers. And we need to find the smallest fraction number by using the numbers that are present in the array. Okay. For example, the array was given us is like this, and k's value is 3. Let's take this example for example. Okay, and all the elements are of array are unique, and array is in sorted increasing order, and you have to return the answer of array, answer in an array integer that contains number used at k smallest fraction. For example, if we want the fractional value here, so our main condition is that our numerator should be less than our denominator. If this condition is true, then we got the fractional value. Okay, for taking this condition into our radar, we can make some pairs that 1 by 5, 1 by 2, 1 by 3, 2 by 3, 2 by 5, and 3 by 5. This type of pairs that we can make by satisfying this condition. So all the pairs can have some value. Okay, and we want third smallest. If this pair gives the third smallest fractional value, then we need to return this numerator and denominator like this. We need to return an array that contains numerator and denominator. Okay, so this type of array we need to return for solving this question. Okay, now let's take this condition and to copy it and paste it here. Okay, at this page. Okay, now our k, what is the condition for k? If our k is 3, okay, our k is 3, then we need to return the value 0.4, and then we need to return the numerator or denominator's value here. If our k is 3 and this is the 0.4 is the third smallest, then we need to return an array that contains 2 by 5. Okay, so our k can be go up to k is greater than 1 and less than n into n minus 1 by 2. Okay, so this is the constraint for k. So n minus 1 is the sum of the numbers. Okay, so this is the main condition that we need to follow here. If our numerator is equal to denominator, if this condition, then our answer will be 1. If our numerator is greater than denominator, then our answer will becomes into more than 1, greater than 1. But we only want this condition. Why? Because we want the fractional value there. So what is the by taking this condition into our radar, what is the possibility, what is how much number of pair that one can be made by using these numbers, by using the numbers that are present in the array. So is one can be made a pair with the array size is 4. For this array, the array size is 4. So one can be go with these three integers. So these three integers and its value is less than 1. So why? Because our numerator is smaller and denominator is greater. So we can go with 1 by 5, 1 by 2, and 1 by 3, that is here. For the 2, how much pair that 2 can be made by using the numbers that are present in the array. So 2 can be made 2 pairs. First is this by using this, and second is this by using this. Okay, how much pair that 3 can be made by using the number that are present in the array. So it will only made 1. Okay, this is the pair that it will be made from using the array, using the number that are present in the array. So this is the condition, 3 plus 2 plus 1. Okay, now what is our approach to solve this question? What is the approach to solve this question? So let's erase this. Okay, so its condition is this. Our main condition is numerator should be less than denominator. So it will gives us the fractional value. So this is our main condition. Now from this point we need, so our faith is that we have a function that will return us count, numerator value or denominator value. Okay, we have a function that that returns us count, numerator value or denominator value, and we are passing that function as a and target value. Okay, what is that count, what is the number, what is the numerator, what is the denominator. Okay, now at this point, by using for using this function efficiently, we need to apply the binary search over this array. Okay, so for the binary search we want 2 point, low and high point. The low point is how to calculate low point in the fraction, how to calculate the lower point in the fraction. If we are taking 1 by 5, that means smallest value from the integer, smallest value from the array, smallest value from the array of 0, divided by maximum value that are present in the array, that means array of n minus 1. If we are taking this condition, then we got 1.1 by 5, and that will give us 0.2, that is the smallest value that we can produce by using the number that are present in the array, smallest fractional value. So 1 by 5 is the lower value and 1 is the higher value. Why? Because we need to satisfy this condition, our fractional value is less than 1. Okay, now what the this function works, what is the main work of this function? So it will return count, number, numerator or denominator. So how to use this efficiently? So by using this low and high pointer, we can find the middle point of this. So middle point of this is 1.02 divided by 2. Let's take it's 6.2, 6.2 or something. Okay, let's take this as a 6.2 or something, where this is not the what we say, this is not the uh, original decimal value. It is only, we are taking only 0.2, 0.33. It is at this point 0.666663 7. No, so this is value that we got as a mid value, 0.62. We are passing this value to this function, this target function. So this is the lower point, this is the lower point, and this is the higher point. Okay, at this point 1, and this is the higher point. So our value, our target value is 0.6, 0.62. It is lies between, somewhere in between this. So if our target is lies between somewhere here is 0.62. Okay, our target is at this point, and our faith for this function, it will return us a count. What is that count? What is the actually that count? It will return the count that from that target point to lower point, target point to lower point, how many number of pairs that are present in this position, in this, in between these 2 points. Again, it will return us a count, that count is lies between low to target point, low to target point. And at this point we have, at this point we have 1 2 3 4 and 5 pairs. At this point, this is the main the 0.62 point. Let's take this 0.62, and 1 by 5 we have 1 by 3 pair, 1 by, sorry, 2 by 5 pair, 1 by 2 pair, and 3 by 5 pair from this point to this point. And we are calculating the count of pairs, how many pairs that are present in between these 2 points. So it will return 5, 1 2 3 4 and 5 points, and the last point at this point. So it will return 5 as a point. If our case value, if our case value is 3, if our case value is 3, then our answer is lies somewhere between there at this point. So our answer at this point, and we are finding the values of this point. So for finding this answer, we need to update our high pointer, we need to find our answer in this portion. For that, we need to update our high pointer as a mid pointer. Okay, as a mid pointer. Now let's write some pseudocode for that. Okay, here let's Okay, pseudocode for that. If our k is less than count, this count, if our k is less than this count is 5 at this position, count is 5 and our k is lies between somewhere here. If it is less than count, then we need to update our high pointer at this point. Okay, and else if our k is greater than count, if our k is lies between somewhere here and our count is 5, then we need to find our answer at this portion. So we need to update our low point as a midpoint. Okay, so these two conditions that we need to take care of. So let's first write the code for this function, and after that we are discussing about this function. This function is the main abstraction of this code. So let's make this as a full screen. This is an Adobe platform. Now first pointer, we are finding our n, that is array dot length. Okay, array dot length. Let's take a 2 pointer, low pointer at array of 0 divided by double array of n minus 1. So our low pointer is taking first numerator is the smallest number and denominator is the largest number that are present in that array. Now we are taking a high pointer as a 1. Our condition is while low is less than 5. Now we are finding our midpoint. What is our midpoint? Low plus high divided by 2. So this will find, this is the code for the finding the midpoint. Now we have a faith in one function that returns us a count, numerator value or denominator value. So we have a faith in one function. Let me take this onto this. Okay, we have faith in one function that will return count, numerator value or denominator value. Okay, the denominator value, which denominator value? So the numerator or denominator value is that it will nearby to the that target point, the value of numerator or denominator, it will be nearby that target point or the value of that. Let's take this example at this point. Okay, at this point we are returning the value of that one pair, numerator or denominator pair, that is the nearby pair from the target point, and its value is the greatest value in between all the pair that are present from low to target. Okay, so that function return us numerator, denominator or count. Okay, we are providing array or mid from this, and we are collecting that into the integer array. Okay, now we are checking that is our k is less than that count of 0. What does this mean? Okay, let's take the color check. Now we are at this point. Now, okay, this count array contains for the first index count, second index numerator, or the third index denominator. Okay, we are comparing the k with count of 0. We are comparing our k with count of 0. Okay, let's run our high pointer at this point. Okay, after that we are checking that is our k is greater than count of 0. If this condition is true, then we are updating our low as a mid. And in the last part, if this condition is true, then we are returning new int which contains count of 1 and count of 2. If both conditions are true, then we need to return an array that contains numerator or denominator. At this point, the count of 1 contains numerator, count of 2 contains denominator. So at this point, we are returning this array from this point, and if we can't find anything, then we are returning null from this point. So we need to discuss this function, what the functions work here. So basically, let's take the array as an 1 3 1 2 3 5 7 or 11. Okay. For finding that count, numerator value or denominator value, for finding these three conditions, for finding these three values, okay, for finding these three value, we need to fix our denominator value. We need to fix our denominator value. If we are fixing our denominator at this point, so we are multiplying, we are checking that our target is less than this pairs, is our target is less than 1 by 5, 2 by 5 or 3 by 5. Is these conditions is true, if this conditions is true or not. Okay, now we are checking this condition. If this condition is true, then we are updating our denominator point. For that, for the 7, we did not worry about these three conditions. Why? Because our main condition is that our numerator is less than denominator, and it will give us the fractional value. If we are increasing this point, if we are increasing the denominator value, then it will always giving us the smallest number. So if our this condition is true, 3 by 7, then we can obviously say that it will always be less than that target value. But if we want to add some numbers here again, some pair, that is, if 5 is 7 by 5 is there, 5 by 7 is less than target. So for that we need to check, that if this number is less than target or not. After that, again update our denominator. For again, did not need to check that for this. We did not need to check that these numbers. Why? Because it is always been less than our target. So for this, we can say that 1 upon 11, 2 upon 11, 3 upon 11, 5 upon 11 is obviously less than target. But if you want to add this pair also, then we need to check that. For that, we need to check what 7 by 11 is less than equals to target. Okay, so this is a approach. So let's write some code here at this point. Now we are taking that, for we are finding the count here. Okay, count as 0 first. We are finding the numerator value. So we are initializing our numerator here as a smallest value that are present in the array, and denominator is the largest value that are present in this array. So we can easily update this value. Okay, we can easily update that value. So our numerator is array of 0. Okay, and our denominator is array of n minus 1. Okay, now we are checking that I what is the i's work here. We are checking, we are fixing our denominator at this point, and we are checking that is I upon j is less than our target. Is If it is, then I update the I. Is I upon j is less than our target, then update the I. If it is true, then update the I. So we are writing that array of I divided by array of j is less than equals to target. If this condition is true, then for that we are initializing our fixing our denominator here. Okay, this is the okay. Now we are checking that is our array of I is less than equals to array of j. If it is, into target, for the correcting decimal, for we want the correct decimal, we don't want correct decimal point here, so we are writing this condition as this. Okay, if this condition is true, then okay, if this condition is true, then we are updating our I as a I plus plus. And now if we are at this point, we have count that these numbers are smaller than target. Then if we are updating our denominator, then we did not want to check we did not need that, we did not need to check that again also. Then for that we are updating our count as plus equals to I. Okay, now after that, now after that in that if our target is there, and let's make some pair here, 1 by 2, 1 3 by 5, 2 by 3. Okay, for example, let's make some pair. So we need this value also. This function returns count numerator or denominator, so we need this pairs value also. So we are checking that at this position, if our I is at this position, then we are checking that is our array of I minus 1 upon j is greater than numerator upon denominator. Okay, let's write that is our array of I minus j, I minus 1 upon array of j is greater than numerator upon denominator. If we are at this point, our array of I minus 1, that means 5 divided by 7, is always been greater than 1 by 11. 1 by 11 gives the smaller fraction value and it is gives the larger fraction value. So for the decimal, we are writing that like this: while array of I minus 1 into denominator is greater than array of j into numerator. If this condition is true, then if this condition is true, okay, let's make some space. If okay, if this condition is true, then we are updating our numerator as a array of I minus 1 and denominator as a array of j. So we are updating this. So this is the code. Let's copy it and make the function first. So it will return an array. So make it public static int array, that the function name, and int array and double target. Okay, now paste this code, that code here, and okay, shift enter. Okay, let's again make it align. Okay, now we are at this point. Now we need to initializing our n. N is a array dot length. Okay, array dot length, and we are taking count here, numerator, denominator. Now from this point we need to return and new array, new int of that will contains count numerator value, okay, numerator value and denominator value. From this point we are returning our main array that will contains count numerator or denominator. So this is the code. Let's try to run this code. So it is it. Okay, one error, sample import java.util. Okay, at this point. Okay, let's try to run it again. So rejected. At which point this code is rejected? Let me check. I initializing I, updating I, checking that if I is greater than 0, then check this. Okay, if I is greater than 0, let's try to run it. So at this point our code was stuck. Okay, why? Because we are using I minus 1 function here, and if it is I is less than our array index, then it will give the error. So let's try to submit it. Will it be run for all the test cases or not? So all the test cases are passed here. So this is the code for this question. So I hope you understand the question and the solution of this question. Thank you for watching.